So in this video, we'll be finding the area of trapezoids and then using our area to find missing values within a trapezoid. So what you see on the screen here is you see two different trapezoids. These two trapezoids are identical, and I want to go over the components of those trapezoids so you really know what you're seeing on the screen before we talk about its area. So what you're going to notice with the trapezoid is that its height also forms a 90-degree angle, but the different thing with the height here that is different than other shapes is that that height value connects the two bases. Remember, in a trapezoid, we have one pair of parallel sides. So that height is going to connect the two bases that are parallel to each other. That's what we're seeing here. So here you see you have base 1, you see you have base 2. They're connected using a 90-degree angle by a line that represents the height of that trapezoid. So that's what you see in each of these pictures here. Now, what we're going to do is we're going to use two trapezoids to derive the equation of a trapezoid. So here, you'll notice I flipped that trapezoid around. And what's really cool about trapezoids, if I can get this perfectly flipped around, is that trapezoids also form a parallelogram when you mix two identical trapezoids together. So here, if you look very, very carefully, you're going to see a parallelogram. And we know the area of a parallelogram is calculated by taking the base of that parallelogram times the height. Now, what's different for a trapezoid compared to a triangle is that we have two values being added together to represent our base. Our base of that parallelogram is going to be base 1 plus base 2 together. You can see they're identical on each side, both of them being added. So our area of this parallelogram is going to be the two bases, base 1 plus base 2, added together and then multiplied times the height. Now, we only want the area of one of these trapezoids, not both. And so that, in order to represent that, we need to use either the divided by 2 or multiplied by 0.5. So the equation I'm going to write down for the area of a trapezoid is 0.5 times our base, represented as base 1 plus base 2, all multiplied by the height. So let's dive in and find the area of this trapezoid. I know that area is calculated by taking 0.5 times base 1 plus base 2 in parentheses times our height value. So here we're going to find those values in order to calculate our area. So when I look, first thing I look for is my height. And my height is going to be this value right here that represents and connects the two bases with a 90-degree angle, finding and representing the actual height of that trapezoid. So my height is equal to 5. Then I need to find my two bases, which are the two side lengths that are parallel and connected by the height. So I typically do base 1 as the bottom, which is 12, and base 2, which is, in this case, 8 on the top. Now, it doesn't matter which one is which. All that matters is you are consistent. One is base 1 and one is base 2. So let's go ahead and put those into our equations. We have 0.5 times, in parentheses, base 1, which is 12, plus base 2, which is 8, multiplied by our height, which is 5. Now, as I evaluate this, I need to think about my order of operations. And I know that my order of operations calls for me to do my parentheses first. And that still applies here. So I'm going to add together the two numbers in parentheses, and 12 plus 8 gives me 20. Now, when I look at this, now this is just a string of multiplication. So I can take 0.5 times 20, which becomes 10. 10 times 5 is 50 inches squared. So my area of this trapezoid is 50 inches squared. Now, if I wanted to find my perimeter is going to be all four sides added up. So it's going to be 8 plus 7 plus 12 plus 6. And all of those added together, notice the 5 is not included because it's not a side length, gives me a perimeter of 33 inches. So now let's find the area of this trapezoid. So here, when I take a look at this trapezoid, I notice that it looks like it's on its side, but finding those key values is going to be the same type of process. So remember, to find our area, we need to have 0.5 times base 1 plus base 2 in parentheses times the height. So we're going to look for that base 1, base 2, and height value. When I look at this, the first thing I look for is height. Height is typically an internal value. It's forming a 90-degree angle connecting the two bases. So knowing that, I can pick base 1 to be 20, base 2 to be 17, as those are the two items connected by the height, and then height is equal to 8. So if we substitute those values in here, base 1 is 20, plus 17 is base 2, times our height, which is 8. Now, because of the order of operations, we want to make sure we're very careful as we calculate this area. I'm always going to start with the parentheses, so 20 plus 17 is 37. So I have 0.5 times 37 times 8, and now I can take 0.5 times 37 times 8, and I find an area of 148 feet squared. Now, if I were to calculate my perimeter, that's going to be adding up all of the side lengths, so I can see 17, 10, 20, and 11. So 17, 10, 20, and 11. Notice that the 8 is not included because it's a height, it's not an actual side length. So our perimeter here is equal to 58 feet. So now let's try to use what we know to apply area and find a missing value by going backwards throughout this process. So we know that our area of a trapezoid is calculated by taking 0.5 times, in parentheses, base 1 plus base 2 times the height. Now if I look, I can find my height pretty easily. It's connecting two bases with a 90-degree angle. So my height is 8, and then I have base 1, which is equal to x, and base 2, which is equal to 18, because those are connected by that height value. So here we have 0.5 times base 1, which is x, plus base 2, which is 18, times our height, which is 8. And then we know our area is 168, so that can go in place of area. Now, when I look at this, it looks like it's going to be pretty tricky, but what I notice right off the bat is I have 0.5 and 8, and that's a long string of multiplication. So because multiplication is commutative, it means that we can multiply in any order. So we have 0.5 times 8, which is going to give us 4, and then x plus 18 goes in parentheses. And that makes things a little bit easier to look at, because now that I've combined the 8 and the 0.5 by multiplication together, I can now distribute. So I have 168 is equal to 4x plus 4 times 18, which is 72. I can then subtract 72 from each side. So 168 minus 72 leaves me with 96. And then I can divide that by 4 to find that x is equal to 24 inches. And if I look at my picture, that seems to fit right in. So let's try one more example here. So we have area equals 0.5 times base 1 plus base 2 added together times our height. So I'm going to start off by finding my height, which I know is a 90-degree angle connecting two bases. So my height is going to be 2x minus 4. Then my base is going to be the 18, so that's base 1. And then base 2 is going to be 14, because those are the two side lengths connected by the height. So our area is 80, so I'm going to substitute that in right away. And then we have base 1 is 18, plus 14 is base 2, times our height, which is 2x minus 4. Now, I know that if I can simplify parentheses, I should do so. So we have 80 is equal to 0.5 times 18 plus 14 becomes 32. And then I still have the 2x minus 4 in parentheses. I can then multiply 0.5 and 32 together. So we have 80 is equal to 16 times 2x minus 4. Now, this is a problem where I can distribute because I have one set of parentheses and a number out in front. So I have 80 is equal to 32x minus 64. Then to solve this equation, I can add 64 to each side. So I have 144 is equal to 32x. And then to end that problem, I take both sides and divide them by 32. And I find that x is equal to 4.5 centimeters. And I can take that x value, put it in here, and find that missing side length.